The next question that we have is classify the given pair of surds into like surds and unlike surds. So we have to identify whether these surds are like or unlike. Like means similar and unlike means different. Now, for any surd to be similar, there are two things that are necessary. One, the number here, that is the order should be same, and the number inside, that means the radicand should also be same. So we try to simplify both our numbers, and then we will compare. Then we will try to see whether these are like surds or unlike surds. So let us first try to solve square root of 52. If I want to find out square root of 52, we all know it is not a perfect square. Okay, so we try to factorize it. 2 2s are 4, remainder 1, 2 6 are 12, 2 13s are, and 13 1s are. So this becomes 2 into 2 into 13. Now, since this is a square root, I make the pair of two similar numbers. Since I got a pair of two similar numbers, in the next step, instead of these 2's, I write down only 1, 2, and square root of sign disappears. What about 13? For 13 children, 13 doesn't have a pair with it. It doesn't have a pair. So therefore 13 remains as it is along with the square root sign. So this becomes 2 root 13. This becomes 2 root 13. Now, and our next number is 5 root 13. So if I compare both of them now, okay, if you look at both of them, this is 2 root 13 and 5 root 13. If you see the numbers inside this root sign are similar, also this order is similar, and therefore we'll say that these are like surds. These are like surds. 2 root 13. But the actual question is not 2 root 13. Actual question is what? Square root of 52. So in the next step we'll write down square root of 52 and 5 root 13 are like surds. Let us have a look at the next question. Now let me find out what is square root of 68 and 5 root 3. Children, let us check the order first. Here there is no number, that means there is a square root. Square root, that means 2. And here also this 5 is outside. It's not here inside the root sign. That means this is 2 and this is also 2. So our first condition of order being similar is satisfied here. But what about the radicands? The number inside these root sign are different. So let us solve this first. Okay, so I'll just solve square root of 68. Square root of 68. Let me factorize it. 68. The first prime number is 2, with which I'll factorize it. 2 3s are 6, 2 4s are 8, 2 1s are 2, remainder will be 1, 2 7s are 14, and 17 1s are. That means square root of 68 is going to be equal to 2 into 2 into 17. Now, since this is a square root, I'll make a pair of 2. So in the next step, square root goes for 2, and 17 does not have a pair with it. So this remains square root of 17. So we got 2 square root of 17 as the answer. And our next number is 5 square root of 3. I cannot solve this, right? So if you check these two numbers, 2 root 17, which I got here, and this 5 root 3. These are having same orders, right? But they are not having the same radicates. The number inside the root sign are different. In the first example, we were having both the numbers inside also similar, and that's why they were surds. But here, that's not the case. Here, these numbers are different, and therefore we'll say that both numbers are unlike surds. But 2 root 17, original question is root of 68 and 5 root 3 are unlike surds. Let us check the next example. 4 square root of 18 and 7 square root of 2. So here here if we see here the orders are similar. Okay, now what about the radicands? The number inside this root sign, the radicands are different. So first we need to reduce this. We need to solve this properly. So I'll find out what is square root of 18. Okay, once I find out the square root of 18, we'll try to solve this. So now, how am I going to do this? 4 square root of 18. Okay, you can factorize it. 2 9s are, 3 3s are, 3 1s are. So this will be 4 outside the square root sign, and inside you'll be having 2 into 3 into 3. Now you have to make, this is a square root, that means you have to make the pair of two similar numbers. You cannot make a pair of 2 and 3. Okay, so now this becomes 4. Inside the square root you'll have 2. And what will happen to this? Since we have a pair for this, this will remain only 3. The square root sign will disappear. See, I'll repeat once again. This 4 will remain as it is, multiplied by this 2 does not have a pair, so this will remain square root 2. And for this 3, since it is a pair, this will remain only single 3. And therefore we'll get this as 4 3s are 12 root 2. So this will be 12 root 2. And the next example is 7 root 2. So since we have got the radicands similar and the order similar, we'll say 4 root of 18 and 7 root 2 are like surds. Now again, if we see here that the orders are similar, what is different are the radicands. The number inside the root sign are different. We have 12 and 3. So let us try to solve those first. I'll take square root of 12. Okay. So if you factorize the square root of 12 will be 2 6 are 12, 2 3s are 6 and 3 1s are 3. So this will be written as 2 into 2 into 3. Since this is a square root, I'll make a pair of 2. In the next step, we have only single 2. And 3 is not having a pair, so this becomes root 3, which is 2 root 3. The next one. The next number that they have given us is 6 root 3. If you look at both these numbers, children, the number inside the root sign is same and also the order is same. And therefore, we'll say 19 root 12 and 6 root 3 are like surds. Next example. In the next example, we have 22 and 23. But if we try to factorize, children, if I factorize 22, it will be 2 11s and 11 1s. Similarly, if I factorize 33, it will be 3 11s and 11 1s. You're not going to get any common number here. You're not going to get any pair here, right? That means this 22 will remain as it is when you solve it, and when you write down 33, that will also remain as it is. And therefore, we will compare the orders. Orders will remain the same. Whereas 22 and 33, we cannot solve in this, right? So 22 and 33 will remain as it is, and therefore we'll say 5 root of 22 and 7 root of 33 are unlike surds, because we cannot reduce them and find out any answer. And if I compare 22 and 33, they are totally different numbers, and therefore they are unlike surds. The first number here is 5 root 5. So 5 root 5 we cannot reduce further, so we'll keep it as it is. Square root of 75. We'll try to factorize what is 75. So I'll find out what is square root of 75. Do not forget to put the square root sign. Let me factorize this. 5. Okay, the first number will be 2. So we'll first factorize it with 2. Okay, but it is not divisible. This number is not divisible by 2, and therefore the next prime number is going to be 3. So the next 3 2s will be 6. Remainder will be 1. 3 5s are 50. Then this will be 5 5s are 25 and 5 1s are 5. So that means when I'll solve this, I'll get this as 3 into 5 into 5. Now, if I want to write down this in the form, I'll make this pair. 3 doesn't have a pair with it, therefore it will remain root 3. Whereas 5 has got a pair with it. So this will become root 3 into 5. So which can also be written as 5 root 3. So this is your final answer. Now the other pair is 5 root of 5. Now the orders are same, children, but the number inside, that is the radicands, are different. Here there is 3 and there is 5, and therefore we'll say 5 root 5 and root of 75 are unlike surds. These are unlike surds. The next question is simplify the following surds. In this you just have to factorize and find out what is the simplest form of this. It's very easy. Whatever we have done previously, we have to follow the same method. Like for example, if I have to find out square root of 27, I'll factorize it. 3 9s are 27, 3 3s are 9, and 3 1s are 3. So this is square root of 3 into 3 into 3. Okay. Now, since we have the square root here, I'll make the pair of two numbers, and because this is a pair, in the next step only 1 3 remains, and this other 3 does not have any pair with it, and therefore this has root sign with it. So this becomes 3 root 3. That's it. This is our answer. Only this much we are supposed to do. So square root of 27 is nothing but 3 root 3. Let us have a look at the next example. Square root of 50. So my next question. Square root of 50. So I'll again factorize it. Okay, 50. See, you might think, okay, 50 is directly divisible by 5. No, you have to go properly. You first start with the number 2. There you have to start with the smallest prime number first. So the first prime number is 2, then 3, then 5, then 7, and so on. So I'll first start with 2. So 2 into 25 will give me 50. Now 25 is not divisible by 2. So after 2 comes 3. But this is not even divisible by 3. The next prime number is 5. So this is divisible by 5. So 5 5s are 25 and 5 1s are 1. So root of 50 can be written as 2 into 5 into 5. Now since this is a square root, there is a no number here. That means it is a square root. Then you are going to make a pair of two similar numbers. So since we got a pair, 2 does not have a pair with it. So square root 2 remains as it is. But this 5 becomes this, and the answer will be 5 root 2. Suppose if you have cube root 3 here, no, then you will make pair of 3 similar numbers. If you have 4 root here, then you will make pair of 4 similar numbers. But since there is no number here, that means it is a square root. Let us have a look at the next example. Square root of 250. Square root of 250. Let me factorize it. I start with 2 first. 2 1s are 2, 2 2s are 4, remainder 1. 2 5s are 10. Now 125 is divisible by 5. 5 2s are 10, 5 5s are 25. Then this will be 5 5s are 25 and 5 1s are 1. So the square root of 250 is going to be equal to 2 into 5 into 5 into 5. So this will be what, children? We'll make the pair of two similar numbers. 2 and 5 I cannot make. So I'll make the pair of these two numbers, suppose. Okay. So what happens to this? 2 does not have a pair. This does not have a pair. So it remains as it is. So this becomes 2 into 5. It will remain as it is. Okay. When you don't have a pair, you write it along with the root sign. But this will become 5. So this will become 5. And inside the root, so for this 5 I have written here, and inside the root 5 2s is 10. So this is your answer. 5 root 10. Next question. Square root of 112. Square root of 112. So I'll factorize this. 112. 2 5s are 10. Remainder 1. 2 6 are 12. 2 2s are 4. 2 8s are 16. 2 1s are 2. 2 4s are 8. 2 7s are 14 and 7 ones are. So these are the numbers that we get, which we'll write down under the root sign. There are 4 2's there, 2 into 2 into 2 into 2, and there is 1 7. Okay, now since there is a square root, I'll make pair of 2 numbers. So for this 2 I write down 1 2, for this I write down 1 2, and 7 does not have a pair, so it will remain square root of 7. So 2 2's will be 4 square root of 7. This is the answer. Next question, square root of 168. Square root of 168. So how do I do this? Again I am going to factorize it. So let me factorize square root of 168. 2 8s are 60, 2 4s are 8. 2 4s are 8, 2 2s are 4. 2 2s are 4, 2 1s are 2. Now 21 is not divisible by 2, so we'll have it with 3. 3 7s are 7 1s are. So we'll copy those numbers here. 3 2's, so 1 2 3, 1 3 and 1 7. Again I am going to make pairs, so of 2 similar numbers. So this is one pair which I'll have. These are not having any pairs. So for these 2 I'll write down 1 2, and the remaining numbers will remain in the root sign. So this will become 2 square root of 3 2's are 6, 6 7's are 42. So your answer is 2 square root of 42. The next type of question that we have is compare the following pairs of surds. Now compare means, see previously what we did with was we were just finding out whether they are like surds or unlike surds. But now here we are going to compare. We are going to find out which one is a greater number and which one is a smaller number. Okay, now for that, one thing that you have to compare is the number inside the root sign. That means you have to compare the radicands, okay? But when you are going to compare the radicands, you don't have to keep these 7 and 5 outside. You have to take those inside and then you have to solve them. How you are going to do this? Have a look. Now, 7 square root of 2. I am not supposed to keep this 7 inside. I'll take this 7 in. I'm not supposed to keep the 7 outside. I'll take this inside. But when this 7 goes inside, it takes this order along with it. Now the order here is 2. This is square root. So when it will go inside, it will have this 7 square. When this goes inside, this takes this order along with it. And 2 is already inside. So square of 7 is 49 into 2. And 49 2's will be 98. Right? So we have to keep this as it is. Now, 5 root of 3. I'll take 5 also inside, but when it will go inside, it will take this root also along with it. So this will be 5 square into 3. See, this 5 went inside and this 3 was already inside. Now the square of 5 is 25 into 3. So 25 3's is 75. Now you are going to compare these two numbers, children. These two numbers. 98 and 75. There is no number outside now. So you just have to compare the number inside. Whichever is the greater number, that surd is the greater surd. Like for example, in this 98 is greater than 75. Therefore, square root of 98 will be greater than square root of 75. You can write down like this. And therefore, square root of 98 is what? 7 root 2 is greater than 5 root 3. This is how you find out your answer. In the next question, we see there is no number outside this square root. And inside you have 247 and 274. So looking at the numbers directly, we can compare. See, 247 is less than 274. Yes, and therefore we'll say square root of 247 is less than square root of 274. This much only. Let us have a look at the third question. 2 root 7 and 28. Now, what happens to this 2 root of 7? See, I told you that you cannot keep any number outside. So for this 2 root of 7, we take this 2 inside. When we take this 2 inside, it gets square on it. 2 square into 7. This 7 was already inside and this 2 went inside, so it became 2 square. So square of 2 is 4 into 7, which is 28. And our other pair is already square root of 28. So if you look at this and this, they are both equal. So I'll say square root of 28 is equal to square root of 28. And therefore, this square root of 28 is 2 root of 7. So 2 root of 7 is equal to square root of 28. Now here we are going to take 5 inside and then we'll compare the radicals. So let us solve this. 5 root of 5. 5 square root of 5. So here this 5 will go inside, it will come inside. Yes, so it will be 5 square into, this becomes 5 square and this 5 was already here. So this becomes 25 into 5, which will be 125. The next one is 7 root 2. 7 root 2. So again this 7 will go inside, so it will become 7 square. And this 2 inside already. 7 square is 49 into 2. So when you do 49 into 2, you will get it as 98. Now what you are going to look is, you are going to look at the numbers inside the root sign. So 125 is greater than 98. Therefore, we'll say square root of 125 is greater than square root of 98. But square root of 125 is 5 root 5. So 5 root 5 is greater than 7 root 2. In the fifth sum, we are going to take 4 inside and 9 inside, right? So 4 root of 42 will become, inside the square root, this 4 will go inside. So this becomes 4 square into 42. So this will, the square of 4 is 16 into 42. So you'll have to multiply this 42 into 16. 6 2s are 12. 6 4s are 24 plus 125. 1 2s are 2 and 1 4s are 4. So 2, 7 and 6. So this is going to be square root of 672. Then next, 9 square root of 2. When this 9 goes inside, children, this will become 9 square into 2, which will be, the square of 9 will be 81 into 2. So when you multiply 80 with the 16, 162. When you look here, 672 is greater than 162. 672 is greater than 162. Therefore, we'll write down square root of 672 is greater than square root of 162. But square root of 672 is 4 root 42 and 162 can be written as 9 root 2. 9 root 2. Next example, 5 root 3 and 9. So first I'll take 5 root 3, 5 inside. When it goes inside, it will become square of 5 into 3. Square of 5 is 25 into 3, which will be square root of 75. What about 9, children? How do I find out 9? Where do I take it inside? See, one easy way is, see, 9 is nothing but the square root of 81. So this is going to be square root of 81. That's how you can do it. Or the other way is, you can imagine 9 going inside, which will be, if 9 goes inside the square, from outside if it goes inside, it will be 9 square. That is the other way in which you can think. So square root of 81. Okay, now 75 and 81. 81 is bigger than 75. So I'll say 75 is smaller and 81 is bigger. Therefore, square root of 75 is greater than square root of 81. But square root of 75 is 5 root 3 and 81 is nothing but 9. Now, 7 is a natural number. If I want to express it in the form of surd, how will I write down? 7 is nothing but square root of 49. Also, 2 root 5. When 2 goes inside, it will become 2 square of 2. And this 5 was already there. So this becomes square of 2, which is 4, and 2, 5, which will be 20. So 49 and 20, if we compare, 49 is greater than 20. Therefore, square root of 49 is greater than square root of 20. And therefore, we'll say, now square root of, this is the original question. So 7 is greater than 2 root 5. Now in the next step of question, you are either supposed to add or subtract certain surds. When you are asked to add or subtract certain surds, you add or subtract only the outer numbers. Like I am going to add 5 plus 8. But that I can do only when the radicands are similar. That means if the number inside the root sign is same, then only I can add the out numbers. So in this case, there is no problem. I can directly add 5 and 8. So I'll add 5 plus 8 and root sign will remain outside. I'll add 5 plus 8. So this will be 5 plus 8 will be 13 root 3. This much. Let me take the next example. The next example is quite different. It is 9 root 5 minus 4 root 5 plus square root of 125. Now if you look here, children, two questions are having square root of 5, but the two numbers are having square root of 5, but then third one is not having that. So I'll have to simplify this, I'll have to reduce this, and then only I'll be able to add or subtract. So until then, I'll keep on writing this 9 root 5 and 4 root 5 as it is. I'll try to solve square root of 125. And how am I going to do that? Like we do always, we factorize it. So 2 6 are 12, not divisible by 2. I'm so sorry. And this will be divisible by 5. This will be divisible by 5. 5 2s are 10. Remainder will be 2. 5 5s are 25. 5 5s are 25 and 5 1s are 1. So this will be 5 into 5 into 5. Okay. Since this is a square root, we'll make a pair of similar number, and in the next step this will be 9 root 5, 4 root 5 plus, instead of this 2 5, now I'll write down only 1 5, and this will remain square root of 5. Now if you look here, you have root 5 and root 5, and now you can add or subtract the outer numbers. So now I'll solve this. 9 minus 4 plus 5. This 9 minus 4 plus 5. These three numbers I will add or subtract, and these root 5 is common to all. Our BODMAS rule says that whenever you are having subtraction and addition, then in that case you are going to add first and then you are going to subtract. So with 9 you will add first 5 and then you will subtract 5. This is going to be our order. And according to that, 9 plus 5 is going to be 14, and 14 minus 4 will be 10. So answer is 10 root 5. This is our final answer. In the third question, if you look, 48, 27, 3, all are three different numbers. So first we are going to solve each one of them. So square root of 48, I am going to factorize with the first prime number 2. 2 2s are 4, 2 4s are 8, 2 12s are, 2 6s are, and 2 3s are, 3 1s are. That means our factors are going to be 2 into 2 into 2 into 2 into 3. This step is not necessary to be written here. You can do it in rough also, but for understanding purpose, I am writing it here. Then 27. If you factorize 27, 3 9s are 27, 3 3s are 9, and 3 1s are 3. So this will be square root of 3 into 3 into 3, and the square root of 3 will remain as it is. Now how do I solve it further? Now I'll make the pairs of 2. Here one pair and the other one pair. So 7 as it is. For this pair I'll write down 1, 2. For this pair I'll write down 1, 2. And this is not, 3 is not having a pair. So this 3 remains as it is. Then for here I'll write down one pair which is 3. And the other one will be root 3 minus root 3. Now 7 2s are 14 and 14 2s are 28. So this becomes 28 root 3 minus 3 root 3 minus root 3. So if you check now, you have root 3 and root 3. That means you can add the numbers which are outside or subtract. So 28 minus 3 minus, there is no number here, that means there is 1. And outside the bracket you have root 3. So 28 minus 3 will be 25 and 25 minus 1 will be 24. So our final answer will be 24 root 3. And now let us check the fourth question. In the next part, we have root 7 and root 7. So there is no problem about it. Now we just have to add or subtract the outer numbers. There is no number here, that means there is 1. There is a fraction here, that is 3 upon 5. And there is 2 here, plus 2. And outside you have root of 7. Now, how do you add all these 3 numbers? Okay, so what I need to do here is, if I have a fraction here, 5, I will multiply all these numbers with 5. Okay, or else the other way is you add 1 plus 2 first, that can be done. So this will give you 3 minus 3 upon 5, okay, into root of 7. Now, when you have to solve this, you can either take this as 3 upon 1 minus 3 upon 5 upon root 7. Now, how will you solve this? You can cross multiply. 3 5s are 15 minus 1 3s are 3 and 1 5s are 5 and square root of 7. So 15 minus 3 is going to be 12 upon 5 square root of 7. This is your final answer.